Could a second Big Bang give birth to a second universe? Would time restart, or would it just be the end? Don't panic, but our planet, or in fact our universe, is doomed. Roughly 6 to 7 billion years from now, the Earth will be vaporized as our Sun expands into a red giant and swallows our planet. Other planets in our solar system will follow suit, leaving nothing behind. Scientists may just have narrowed down on the event that might cause the extinction of our universe. The heat death of the universe is a theory on the ultimate fate of our universe. It suggests that our universe will evolve to a state where there's no energy left for chemical or thermal processes, and would therefore be unable to perform functions that decrease chaos, or, as it is scientifically known, entropy. Though it's called heat death, the concept does not imply any particular temperature. It only requires that the temperature fall to the point where work no longer occurs, because everything now is the exact same temperature. Basically, this is the point at which the universe would reach thermodynamic equilibrium. The idea of heat death stems from the second law of thermodynamics, which states that entropy or lack of useful work comes from an isolated system. So, in other words, there's a tendency in nature to dissipate mechanical energy into thermal energy. In time, the mechanical movement of the universe will wear down as work is converted to heat because of the second law. But these bodies will cool off. Take Jupiter, for example. The planet is incredibly hot and unsustainable for life, but the Moon is already too cold to sustain life too. The final state in this view is described as one of equilibrium in which all motion ceases. The universe ends up uniformly cold, dead, and empty. When the Sun expands and engulfs the planets belonging to it, it would still be one in a billion stars causing events in a single solar system in a single galaxy. How does the rest of the universe play into this? Our best understanding of physics suggests several options for the universal apocalypse, chief among them being heat death. And though the idea may sound like a slow, drawn-out end and eventual fade-out of existence, the truth is heat death is far worse than being burnt. Once the universe reaches heat death, everything everywhere will be the same temperature, which means nothing interesting will ever happen again. Stars will die, matter will decay, and eventually, all that will be left is a sparse soup of particles and radiation. Even the energy of that soup will be zapped away over time as the universe continues to expand. After the development of thermodynamics in the early 1800s, heat death looked like the only possible way the universe could end. But 100 years ago, Albert Einstein's theory of general relativity suggested a different, more dramatic fate. The theory of general relativity says that matter and energy warp space and time. This relationship between space-time and matter-energy extends to the entire universe. The matter in the universe, according to Einstein, determines the ultimate fate of the universe. The theory predicts that the universe as a whole is, at any given moment, either expanding or contracting. It's never the same size. In 1929, American astronomer Edwin Hubble found hard evidence that the universe was expanding, and we have now learned that it expands at 75 kilometers per second or 46 miles per second over 3 million light-years. And if the universe is expanding, it must once have been much smaller than it is now. How much longer will the universe expand? And how quickly it is currently expanding? The more matter and light in our universe, the more gravity. The more gravity, the greater the chances of our universe pulling everything back together and slowing down the expansion. So, as long as the matter inside this cosmic bubble does not go past a certain threshold, the universe will continue expanding the way it is now, eventually reaching heat death and freezing out. But if there's too much matter in this bubble, the expansion will slow down and eventually stop, and then it will begin to contract. A contracting universe will shrink smaller and smaller, getting hotter and denser, eventually ending in a fabulously compact inferno, a sort of reverse Big Bang known as the Big Crunch. Astrophysicists for the longest times have been unsure of which scenario would ultimately play out. Would it be the heat death or the big crunch, ice or fire? A cosmic census might help us find the answer. When scientists tried to add up how much matter exists in our universe, they found that we were dangerously close to this threshold, which should have pointed to the big crunch. But it looks like the expansion rate of the universe is not slowing down. Dark energy is what we call the force that's causing the accelerated rate of the expansion of the universe, and it doesn't behave like anything we're familiar with in the cosmos. Roughly 70% of the energy in the universe is dark energy, and that number is growing every day. And its existence means that no amount of matter in the universe would get to determine its ultimate fate. So we can, at least for the near future, rule out the possibility of a big crunch. As bleak as it may sound, every second in our universe is another step towards the heat death event. It was set in motion from the moment of the Big Bang. The decay time for a supermassive black hole of roughly 100 billion solar masses due to Hawking radiation is about 10 duotrigentillion or 10 to the power of 100 years. So entropy can be produced until at least that time. Some black holes will continue to grow during the collapse of superclusters, and then they would start to evaporate over a period of 10 quatuortrigentillion or 10 to the power of 106 years. After that, we would enter the dark era, consisting mainly of a dilute gas of photons and leptons, with only diffuse matter remaining. Activity in the universe would have tailed off dramatically, with low energy levels and long timescales. And at this moment, it is also possible that our universe would experience a second Big Bang. These events are still trillions of years away. Chances are, our species would also be lost by then, or a very different version of us would exist. But can intelligent, emotional creatures of any kind make it through the end? It seems unlikely, but the laws of physics don't deem it impossible. It would require technology that doesn't even exist in our time, one we can't even foresee right now. But theoretically, we could create an incredibly dense form of matter, so dense that it was on the verge of collapsing into a black hole. If we do that and then quickly clear the matter out of the area, it might force that region of space to start expanding. Could it work? Well, who can tell at this moment? In the words of Franz Kafka, the Bohemian novelist, there's plenty of hope, an infinite amount of hope, but not for us. It's a bleak thought, but we can find some solace in the fact that it's an event too far away to even worry about right now.